Okay, so we're going to be covering section 10.2, which is products and quotients of functions. But before I do that, I just want to review with you 10.1, which is adding and subtracting functions. So let's begin with this first diploma example. I have two graphs here, f of x and g of x, and I want to know what the range of h of x, which is the difference between f and g of x. So where I'm going to begin is at the endpoints. So I have this endpoint here, which is at -2 and -4, and this endpoint up here, which has coordinates of 2 and 8. And then I'll look at the same coordinates for g of x. So I have a coordinate at -2 and 2, and another coordinate at 2 and -4. So if I want to know the range, and those are the y values, for h of x, which is f of x minus g of x, I'm going to look at the endpoints. So I notice that this endpoint has the same x value as that endpoint, and I notice that this endpoint has the same x value as that endpoint. So that's going to help me when I do my range. So h of x is f of x minus g of x. And again, it has to do with the y values. So let's look at the x values that line up here, and to find the difference, we're going to subtract the y values. So this is f of x, this is g of x. So I'll take the y value when x equals -2 and subtract it by the other y value when x equals -2, and I get my first range value of -6. Then I will do the same for my x value of +2. So I'm subtracting f from g. So I take my y coordinate for f and subtract it by my y coordinate for g when x equals 2, and I get +12. So that tells me that my range is going to be from -6 to 12, and of course, since they are endpoints, including both. So I can see that C is the correct option. Now, if you don't like that way of doing it, I want to look at how we can do that on the calculator. So what I can do is take these graphs here and come up with the equation so I can put them into the calculator. So I'm going to use the linear format, y equals mx plus b, so slope y-intercept form. So for f of x, I'm going to figure out the slope of that first. So the slope is positive because it's sloping up and to the right. So I'm going to look at the rise. I go from -4 up to 8, so the rise is 12, over the run, which is from -2 to 2, 4. So that simplifies to be 3. I can also see that my y-intercept is 2. So this equation would y equal to mx plus b. I'll do the same thing over here. So for g of x, my slope, I can see that it's negative because it's sloping down and to the right. So I can see from 2 down to -4, it goes down 6 units. And from -2 to +2, it goes over 4 units. So in lowest terms, that's -3/2. Again, there's my y-intercept, and that's at -1. So this equation would be mx plus b, or -1. So what I'm going to do now is I'm going to put these into my calculator. So I'm going to put f of x in y1 and g of x in y2 and look at the two that are subtracted. Okay, so you can see here I have f of x and g of x. And then here I just take f of x, which is in y1, subtract g of x, which is in y2, and this in y3 will be h of x. So notice I've deselected my equal sign, and the only equal sign I have is for my h of x, because I only want to graph that. Going into my window, you can see that I've set my low value and my high value for x, just like it was for f and g. The endpoints were from -2 to 2. And then I just expanded my y value so I could see the whole graph. Okay, so with that window setting, I hit graph, and this is what h of x looks like. So to figure out the range, I'm going to go from my lowest x point of -2, so trace -2. I can see that has a low value of -6, so that's good. And then trace +2, and that has an upper y value of 12. So now I know that my range from -6 to 12 is actually correct. So same thing, that is the answer. Okay, let's try another one. So we have a graph of f of x, including 3 different points, and the graph of g of x, also including 3 different points. If f and g are defined for all real values of x, which of the following points must lie on the graph of f minus g at x? So again, that's on the graph of f of x minus g of x. So when I'm looking at this, again, my x values stay the same, and it's my y values that are subtracted. So I'm going to look through those points and look for which ones have the same x coordinate. So for example, 2 and 2. And I can look for another one. There's another one here at 4 and 4. This 7 doesn't match up, and this 3 doesn't match up. So I've got 2 different possibilities. So let's look at the 4s. I would keep my x value the same, and then I would subtract the y coordinate for f of x. I would take the y coordinate of f of x, and subtract the y coordinate of g of x. So that would be 15 minus 30. So that would equal to 4 and -15. And you can see that's not any of the options. So let's try for our other points. So when x is the same of 2, I'm going to take the y coordinate of f, which is 5, and subtract the y coordinate for g, which is 6. So I'm going to get 2 and -1. And I can see right there is the option. So again, the important part here is that x stays the same and y is subtracted. Okay, so today we're going to look at 10.2, which is products and quotients. So same kind of idea, where x is going to stay the same and we're focused on our y values. So here's 3 different ways I can write product. I can write it as the f and g function side by side. I can separate them with a multiplication sign, or I can use a closed dot. Those are all the different ways of denoting product. When I have product, I keep x the same and I multiply just the y values. For quotient, I can have my operation right here, so f divided by g defined for x, which is the same as f of x over g of x. So again, I keep x the same and divide my y values. So in terms of the notation, in red you can see I have the names of the function. These are just the names, so we know which value we're going to. In the blue, I have the operation, so either I'm multiplying or dividing. And then the x here is just the independent variable that I'm defining my functions over. So that's just a little bit of a word on notation. Now, because we are doing division, I always want you to watch for any new restrictions. And by new restrictions, I mean because we're doing division, you can't divide by 0. So whatever's on the bottom, in this case g of x, it can't equal to 0. So look for whatever is on the bottom, and it can't equal to 0. So you're going to look at values of x that would cause us to divide by 0. So we'll look at that in just a moment. Okay, let's do an example here where we have a graph, and we're going to look at an example with multiplication and with division. So we have f of x, which is a linear, g of x, which is a quadratic, and we want to sketch the graph of fg at x. So again, when we have those 2 functions side by side, it just really means multiplication. It just means f of x times g of x. Okay, so the mapping notation, we're going to keep x the same. And then you can see that f of x I did in y1 and g of x I did in y2. It could really be in any order, but based on how I did that, my mapping notation would be y1 multiplied by y2. So graphically, what's going to happen when we multiply a linear by a quadratic? Well, that's going to come down to our degree. So a linear function has a degree of 1. That means the highest exponent for the variable is 1. A quadratic has a degree of 2, which just means the highest exponent for x is 2. Now remember in 10C when we did exponent laws, when we multiply 2 numbers together, I keep the base the same and I add my exponents, which means that a linear times a quadratic would actually end up being a cubic function. So let's look at this graphically. So what I'm going to do is I'm going to keep x the same, multiply my y values. Now my graph does go from -10 to +10. So I'm just going to look at numbers that aren't going to go past that. So for example, let's look at when x is -2. I'm going to have -4 multiplied by 0. So f times g at x would be at 0. So my first point will be -2 and 0. Then I'll look at when x is -1. So I'm going to have -3 times -3, which equals to 9. So my point would be at -1 and 9. So right about there. I'll look at when x is 0. -2 times -4 is +8. So 0 and +8. When x is 1, I would have -1 times -3 is 3. So 1 and 3. When x is 2, 0 times 0 is 0. So I'm going to have 2 and 0 right there. And then let's do one more. When x is 3, 1 times 5 is 5. So 1, 2, 3, and then 1, 2, 3, 4, 5. Right about there. So we're going to use what we know about cubic functions from when we did polynomials. So the graph is going to look something like this. Ends in opposite direction. It's going to come up, come down through there, and then turn around and go back up. So something like that, just a rough little sketch of what that would look like. Now, of course, I can check that on my graphing calculator, which I do over here. So you can see in y1, I put f of x. In y2, I put g of x. And then you can see I've multiplied them together. And the points that I was looking at was from -2 to +3. So these were the points that we graphed. And you can see they're the same y values. And my graph here looks pretty bang on to what I did before. Okay, so that's a multiplying. Let's look at the same idea, but we're going to do division. So I have a linear function and again a quadratic function, but we're going to look at the quotient. So really important, quotient and difference. It's important the order that you do it. So see here how I have g over f of x. That's the same as g of x over f of x. So you can see I have g of x in y2. And here I have y equal to f of x, and that will be in y1. So my mapping notation is going to be keep the x value the same, and then I'm going to divide y2 by y1. So in terms of the degree, quadratic has degree 2, linear has degree 1. So remember in 10C, our laws of exponents for division, it's the quotient law. I keep the base the same and I subtract my exponents. So I will end up with a linear equation. So linear equation, I only need a couple points because it's going to lie on a straight line. So again, keeping in mind that this goes from -10 to 10, I'm going to choose a couple points that would fit in there. So as an example, I've got when x is -5, I have 21 divided by -7 is -3. So -5, 1, 2, 3, 4, 5, and then -3. So right about there. That's good. And let's do maybe at 0. I have -4 divided by -2 is 2. So it's 0 and 2. And let's just do one more. We'll do, for example, when x is 3, 5 divided by 1 is 5. So I'm going to go up 1, 2, 3, 4, 5, and then over 3. So right about there. So just like as kind of a rough sketch, it looks like I'm going to have a line like that. Okay, but I said with division, we always want to be on the lookout for some restrictions. So I'm looking for, when I do division, I'm looking for point discontinuity. And that just means a hole in the graph, or a vertical asymptote, which is like that straight line that I can't cross. So what I'm really interested in, because I'm looking at dividing by f of x is in the denominator, I'm really interested right here where it's 0, because I can't divide by 0. So I see that when x equals to 2, f of x equals 0. and that's going to cause me to divide by 0, which is not allowed. So at 2, when x equals to 2, there's going to be a hole in the graph right there. So you can see when x is 2, there's a hole in the graph. So we can check that graphically on our calculator. So I know that x cannot equal to 2. So if I look at it on my calculator, you can see I put it into my calculator. Again, here is my nice line, but you can see right here, there's a hole in the graph. See how there's a little break in the graph? And that happens at x equal to 2. And you can see in the calculator, it even shows that there is an error. So we just want to be on the lookout for that when we're doing division. So let's look at doing this numerically, and then we'll move to doing it with an equation. Okay, so here numerically, I have two different graphs. I have a linear graph for f of x and a quadratic graph for g of x, and I'm going to look at multiplying and dividing at certain x values. So let's start with the multiplying. I have f and g side by side, which just means I'm multiplying, and I'm doing so at -4. So fg at -4 is f at -4 times g at -4. So let's look at our graph for that. At -4, f has a value of -2. At -4, g has a value at -8. Multiplying those together, and it would have a value of 16. Okay, let's try another one. Let's do division. F divided by g at 0. So that is f at 0 divided by g at 0. So let's look at those. So f at 0 is right here, and that has a value of 2. Remember, it's always about the y value. G at 0 has a y value at 8. So 2 over 8 in lowest terms is 1 over 4. Okay, let's flip those around, and we're going to do g over f. So g over f at 2 is the same as g at 2 divided by f at 2. So let me just change the color actually for that. Okay, so at 2, when x is equal to 2, oh, I can see that f and g intersect. And because they intersect, they have the same y value. And that y value is 4. So that would just be 4 divided by 4, which would have a value of 1. Okay, so I just want to end with two more examples, one for multiplying, one for dividing, where we have the function without a graph and without specific number values. So let's look at this. We have fg at x equals to a quadratic. G of x is a linear. I want to determine an expression for f of x. So fg at x is the same as f at x times g at x. So now it's just a matter of substituting. So the product is 6x squared minus 11x minus 10. F of x we don't know, and g of x is 2x minus 5. So to solve this, what I want to do is factor my quadratic. So to factor this quadratic, I know that that factors as 3x plus 2 multiplied by 2x minus 5. On this side here, f of x times 2x minus 5. Okay, so now that I have that set up, it's really tempting to get f of x by itself to divide both sides by 2x minus 5. And I have a little note here. You can never divide both sides of an equation by a variable. It's one of the things you cannot do in math. The reason you cannot do that is because you introduce a new restriction. So if I were to divide both sides by 2x minus 5, that would be true if it was true for all values, but it's not. I see I have a restriction. Since I'm dividing by 2x minus 5, or since I have a 2x minus 5 on that side, I have a potential restriction. Okay, so I cannot divide by 2x minus 5. So instead what I'm going to do is I'm going to use the rules of balance. So since they are equal, that means that they are the same on both sides. So I can see on both sides I have a 2x minus 5. So for them to be balanced, f of x must equal 3x plus 2. So I know that 3x plus 2 is equal to f of x. So I do that without dividing both sides. Okay, let's try one with division. So I have f over g at x is equal to a linear. G of x is a linear. I want to determine a simplified expression for f of x. So f over g at x is f of x over g of x. So f over g at x is just that linear function 2x minus 1. F of x we don't know, and g of x is 2x minus 5. Now we want to get g of x by itself, or sorry, f of x by itself. And I can see right now that I've introduced a fraction. I'm dividing by g of x, so I do have a restriction. 2x minus 5 can't be 0, which means 2x can't be 5, which also means x cannot equal to 5 over 2. So to get rid of my fraction, I would multiply both sides by 2x minus 5. So in doing so, I can multiply both sides of a fraction by something. I just can't divide by anything. So it's okay to multiply both sides of an equation by a variable. I just cannot divide. So by multiplying, you can see that those cancel. So I'm left with f of x equals 2x minus 5 over 2x minus 1. So you can leave it like that, or sometimes the diploma likes to expand that, and it would look like this. F of x is equal to 4x squared minus 12x plus 5, just expanding and grouping like terms. Okay, so to summarize the lesson, when I multiply or divide functions, I keep my x value the same, and I only multiply and divide the y values. So when I'm dealing with functions, I'm always dealing about the y values. I always want you guys to pay attention when dividing functions to any new restrictions that are introduced, because you can't divide by 0. So especially with division, we have to be on the lookout for new restrictions. So those restrictions are x values, and again for the range, you always look to the graph. So range on graph, x, you're going to look for division, and that's super important because friends don't let friends divide by 0. So to finish this off, you guys can do practice 1, 2, 3. That's in the notes. The detailed solutions are on D2L, and then after you've done those, go into your textbook and do those questions as well. So I hope that helped. That was 10.2, and we'll come back for 10.3 after.